Howdy folks, in this video we want to look at adding rational expressions. To show you where we're going, we're eventually going to be adding expressions that look like this. And so our strategy for adding rational expressions is going to be to use the tools that we already know for adding fractions of real numbers and work through those. One potential issue, though, I think, is that students often have worked so much with fractions that they've forgotten how to show the work that goes with working with fractions. And so I want to make sure that we're always reviewing that so we have a common vocabulary. And before I jump into number 2, I'll point out that my guess is if I asked students to find the least common denominator for the fraction 1/3 and for the fraction 1/5, it might be that the answer 15 pops up in their mind as the common denominator for these two fractions. The problem is that although the answer may pop into your mind, you don't necessarily know how to show work for how to get there. Or maybe if you have shown work for how to get there in the past, you've kind of forgotten that. So I want to review that here. And just to motivate this, notice that these two fractions are not quite as easy. It's not quite as easy to just simply identify the LCD here, which is what our goal is. So the first thing I'm going to do is I'm going to write the first denominator, 12, and I'm going to write it in terms of what's called its prime factorization. Now, you don't have to come up with the prime factorization the same way I do. There's lots of ways you can do it. The first thing I'm going to do is just ask what's a number that I know divides into 12, and for example, if I did that, I would get 2 times 6. But 2 is a prime number. There's no reason to look at its factors. But 6 is a composite number. And I ask myself, what's a number that goes into 6? And maybe 2 again. And so I could write it this way. So I could rewrite the number 12 as 2 squared times 3. And this is called the prime factorization. And this is important because we're going to do it for the other denominator. We'll go ahead and write 90 in terms of its prime factorization. So again, you might see many different numbers that divide into 90. So for example, you could do 45 or 2 or 1, or well, 1 and 90, that wouldn't really help you. But you could do 10 and 9 or 5 and 18. There's lots of values. I'll just go ahead and say I could write this as 10 times 9. And I can rewrite 10 in terms of its prime factorization as 2 times 5, and I can rewrite 9 as 3 squared. And so this is its prime factorization. So now that I've got the prime factorization of each of these two numbers, we can go find the least common denominator. So for my least common denominator, I'm going to start off by just taking one of the two prime factorizations and copying it. So I'll take the, for my common denominator, I'm going to need at least a 2 squared factor, and I'm going to need at least a 3 factor. Another way to say that is any least common denominator is going to need at least all of the factors of one of the two fractions. Now, when I look over here, for the least common denominator, I'm going to look at the prime factorization now of the remaining factor. And if I had several more, I'd look at each of them. But here we can see that I've got a factor of 2, but I already have a 2 squared. So there's no need to recopy that. But I'm also going to need a factor of 5, so I'm going to throw that into the mix. And then I'm going to need a factor of 3 squared. Well, we already have 1 3. So I just need a second factor of 3. So notice that when I think about the prime factors of 90, all of the prime factors of 90 show up here. I've got a factor of 2. In fact, I've got more than I need. I've got a factor of 5, and I've got 2 factors of 3. Likewise, if I return to the original prime factorization of 12, I've got a factor of 2 squared, yes, and I've got a factor of 3. In fact, I've got more than that, but I need at least all of the prime factors of each of these two numbers for a common denominator, and I don't want to be redundant if I'm going to call it the least common denominator. So let's go ahead now and compute what the least common denominator is by simply multiplying these numbers together. So if you were to do 2 squared times 3 times 5 times 3, that comes out to be 180. And so the least common denominator across these two fractions is 180. Now, you might say, boy, that's a tough problem. And it is true. It would be sort of mean of a math teacher to ask you to add these two fractions in the middle of some long question. But it's a good idea sometimes to work these more complicated problems to remind yourself where the skills come from. Because unfortunately, as I said before, a lot of times students can look at these two fractions and the least common denominator of 15 just pops into their head without any work. And I want to point out that we need a process for identifying the least common denominator in more complicated scenarios, specifically as we get to these rational expressions that we want to add. So what I'd like you to do now is I'd like you to pause the video and I'd like you to give the least common denominator for 18 and 14. So pause the video and give that a shot. Okay, now that you've hopefully answered that question, let's go ahead and find the least common denominator for some more complicated expressions. What's difficult now is we're not dealing with numbers, so we're not looking at the prime factorization of numbers, but instead we're looking at mathematical expressions. But notice we can still bring in this notion of factors. And in fact, this is already written as its prime factorization, or let me say that it's already factored. And this expression here is already in factored form. Now notice in future examples, I'll make you do the factoring potentially, and that's either me challenging you or just you're working a problem and this happens. But in this case, before we can find the least common denominator, we need the expression to be factored. So our least common denominator is going to take into account all of the factors of each of these two expressions. So we're going to need at least a factor of x minus 5 quantities squared, and we're going to need at least a factor of x plus 1 for this first term here. Then we need to make sure that we have all of the factors of this expression. So we're going to need at least a factor of x and at least a factor of x minus 5, but look, we've already got one over here, so we don't need to recopy that. If we did, we would no longer have the least common denominator, and oftentimes we would make the expression bigger than we wanted to if we didn't do this judiciously. So then the next factor we need is a factor of 2x plus 7. I'm going to go ahead and slide that, make everything a little bit smaller there, and slide that up so I can restate that least common denominator in expanded form. It's customary, you don't have to do this, it's customary when you write out an expression like this, holy cow, to write it as x times x minus 5 squared times x plus 1 times 2x plus 7, where the order of most of these factors doesn't matter, but it is customary when you do this to lead with this factor that's really the factor x minus 0. So let's go ahead and try b now. b is very similar, except that I don't have the expression already written in factored form. So I'm going to have to write this in factored form. So I'd like you to pause the video and try to factor this, because you need practice with it. So pause the video and see if you can factor that. So there I factored that. Hopefully you gave it a shot. Careful here. Notice in this case, before I ought to start doing the process of factoring a trinomial, I pulled out the greatest common factor of 2, giving me this trinomial here that has no common constant, and then I continued factoring it. So now I'm ready to give the least common denominator for this, and we have that the least common denominator, clean that up, would be what? Well, we want to make sure we take into account all of the factors of this term. So we'll do 2x plus 1 times x minus 3. We also need all of the factors of this fraction, and so I'll throw in that factor of 2 there. I'm going to need a factor of 3x minus 1, so I went ahead and wrote it. And then I'm also going to need another factor of x minus 3, which I could write over here, or I could come along and square that given factor. So if I were to just clean everything up, we get that our least common factor would be 2 times 2x plus 1 times x minus 3 quantity squared times 3x minus 1. And you'll notice that we have, in this expression here, we have all of the factors of each of these two fractions. Okay? I want to show you where we're going to be going with this in some of your future classes, The process doesn't change, but maybe the expressions I work with get a little bit messy here. So here we're going to go ahead, this is already factored, and this is already factored. But here we're identifying the factors as the first factor is sine of x, the second factor here is cosine of x. Here we've got a factor of x cubed, and here we have a factor of sine of x. And so when I go to give the least common denominator for these two fractions, it will be, I'm going to go ahead and write it in this order so I don't have to change it, x cubed. I'm going to need a factor of sine of x, and I have that for both of them. So we've got a sine of x factor, and then I'm going to need a factor of cosine of x, also from the first fraction. Folks, this color coding is just meant to kind of help you see that I'm getting all of the factors from the two fractions. It's not a perfect way of pointing that out. So you'll notice I need a factor of x cubed, I've got it. For this denominator, I need a factor of sine of x. For this denominator, I need a factor of sine of x, but I've already listed it, so I don't relist it. Otherwise, it wouldn't be the least common denominator. And then finally, I need a factor of cosine of x. This one's a little bit trickier. Let's give it a shot. Notice that this is, again, already factored. And this is already factored. And here I think we're getting the idea down, so I'm not going to worry about color coding this. We'll just say that the least common denominator here would be, I'm going to need a factor of f of x, because that shows up in the first factor. I'm going to need a factor of g of x, but then I see actually I need two of those. So we'll do g of x squared, because the second fraction requires two factors of g of x, and then I'll need a factor of h of x. Folks, just as a reminder, by factors, notice up here, these two expressions are not two factors, they are two terms, because I'm summing them together. But down here, I've got a product, and so we call each of the two expressions that form up a product, we call them factors. So hopefully that clarifies what we mean by the least common denominator. You can see that structurally nothing changes from this first problem where we wrote out the least common denominator. Let me zoom out a little bit. The least common denominator between these two numerical denominators, we found it to be 180. And then what we eventually had over here, it's the same process, but you can see it certainly gets messier and a little bit more muddled when we're using expressions besides just that are more than just constants. So take a look at that. Let me know if you have any questions. And then what I'd like you to do on your own is I would like you to try to find the least common denominator of these expressions here. Careful here, you'll have to do a little bit of factoring. I'll see you in the next video.